Hi, I'm Ken Trimber. Welcome to the KTA University podcast. Our podcasts are designed to tackle relevant topics in fabrication, construction, cleaning, and painting in both industrial and commercial fields. Today's topic is inorganic versus organic zinc-rich primers. My guests today are both from KTA, Jim Machen and Bill Corbett. Jim, I understand you'll be talking about organic zinc.
Yes, I will.
And Bill, inorganic zinc.
Yes.
Well, let's get started. What is so special about primers that contain zinc?
Well, similar to hot dip galvanizing and zinc metallizing, organic and inorganic zinc primers provide a zinc-rich coating that provides galvanic protection or sacrificial protection. It sacrifices itself to protect the steel, and that's the reason why it's very important in the corrosion protection process.
Okay, so in addition to barrier protection, it gives you this galvanic type protection.
Correct.
Okay, good. What makes one type organic and the other type inorganic? What's the difference between those two?
That's an interesting question. I get that question a lot whenever I'm teaching classes on coatings. And the zinc is a component to both the inorganic and the organic zinc-rich primers. And the zinc is actually an inorganic material because it doesn't contain carbon. So it's not the zinc that determines whether it's inorganic or organic. It's rather the vehicle or the resin system. Inorganic zincs have an inorganic resin system, and the organic zincs have an organic resin system or vehicle system in them. SSPC actually has a paint specification. It's called Paint 20, and it describes several different types of zinc-rich primers, but they're categorized as type 1 inorganic or type 2 organic. And the inorganic zinc-rich primers are further categorized as either water-based post-cure, water-based self-cure, or the ethyl silicate type self-cure, and those are the most common that are used in shops and some in the field. The organic types contain an organic binder, and typically that's the epoxy or urethane, something like that. Those resin systems are combined with the zinc, and occasionally, years ago, they used vinyl in with the zinc, but because of VOC regulations, they have essentially gone by the wayside.
We see in the industry right now that probably the most common use of an organic zinc primer is the zinc dispersed in epoxy, two-part epoxies. Although there is quite a bit of use of moisture-cured urethanes, and to a lesser degree, sometimes zincs are dispersed in alkyd-type primers, and those are typically used for touch-up of galvanized systems.
All right, so the main difference, the zinc is the same as what you're saying. The difference is the binder or the glue that holds the zinc together.
Yes. Correct.
Is it organic or inorganic? Since zinc gives you this sacrificial or galvanic protection, which of those two products is better, organic zinc or inorganic, in terms of that type of protection?
Well, that's also an interesting question. I'm gonna go back to SSPC Paint 20 for just a minute. And talk about levels of zinc, and then I'll talk about why one might be better than the other. SSPC Paint 20 lists 3 different levels of zinc that may be in either an inorganic or an organic zinc coating. You can formulate the different levels of zinc into either. But level 1 is anything greater than 85% zinc in the dry film. Then you have level 2, which is between 77 and 85%, and then level 3 is between 65 and 77%. So you can formulate any of those 3 levels into either types, and they're all considered zinc-rich, but obviously the higher the zinc loading, the better sacrificial protection that you can have that Jim was talking about. But really what it comes down to is perhaps not as much the concentration of zinc, but it's the zinc-to-zinc contact and it's the zinc-to-metal contact. So with the inorganic zincs, because you don't have as much resin or binder insulating the zinc particles and insulating the zinc from the metal itself, you typically will have theoretically better sacrificial protection because of that electrical contact with the steel and with the particles of zinc.
In theory, I agree that inorganic zincs probably give better galvanic protection than do organics. The reason being that you touched on is the zinc-rich particles are primarily dispersed in epoxy or moisture-cured urethane binders, which have a tendency to envelop the particles more and prevent that more intimate metal-to-metal contact that you need. That being said, they still give great galvanic protection. The biggest thing about organic zinc-rich primers is that they have some application efficiencies over inorganic zinc primers. They're more user-friendly, they're a little bit more tolerant of application methods in limited access areas or in difficult areas like we commonly run across on bridges. We can actually brush limited areas with organic zinc-rich primers, and that's just to the nature of the binders that they're dispersed in. When you disperse a zinc-rich primer in an epoxy binder or a moisture-cured urethane binder, they take on the application characteristics of that binder. And they don't dry quite as quickly as do inorganics. So we have the ability to have a little bit more open window for applying the materials.
So I think what I'm hearing is you agree, Jim, that the inorganic may give you better protection theoretically.
Yes.
I think you're saying the application challenges of inorganic versus organic might negate some of that benefit.
Yes.
Well, Bill, in terms of application challenges of inorganic, do you agree that it's tougher than organic, or?
Yes, inorganic zincs are more challenging to apply without question. Not only they are more challenging to apply, but they're more sensitive to thickness. They are more sensitive to curing conditions. They are more challenging to finish coat for a variety of reasons. But I think all those challenges, if you will, if they're recognized, can be overcome. We can do applicator training and make sure that the applicators know what they're dealing with, know the conditions under which the product needs to be applied, and know its limitations or some of its challenges. An example of that is, for years, the Army Corps of Engineers applied vinyl coatings to their tainter gates. And if you know anything about vinyl coatings, they are equally challenging to apply. They dry spray, they cobweb, and to overcome some of those challenges, what the Army Corps of Engineers did is they qualified the applicators rather than going to a different coating system, arguably one that might provide lesser protection because of the application challenges. And I draw that analogy to inorganic zinc versus organic zinc because you may sacrifice some protection just because of application challenges. And if we recognize those, we can overcome them.
Given, I understand your comments on the challenges with applying the coatings, I'm going to ask you two questions. The first one is if I apply all three coats, let's say it's zinc primer, epoxy, intermediate urethane finish. I'm going to apply all three coats in the shop. I'd like to know which of the two primers you folks would recommend. Same question after that, if I applied all three in the field, would that change your opinion? Would you suggest a different primer? So let's go with the shop. 3 coats in the shop. Jim, organic zinc, what do you say?
Organic zinc in the shop is becoming very popular right now, primarily due to the fact that when we have the inorganic zincs applied in the shop, we have to constantly monitor the relative humidities because the ethyl silicate binders used in the organic zinc primers react with moisture to cure. If we have insufficient moisture, we have prolonged cure times. With the organic zincs, because the epoxy zinc-rich coatings are chemically cured, they have a tendency to react faster because of they're more temperature dependent. The heat that we use in the shop sometimes isn't there. We don't have the heating characteristics, but they do have accelerators and faster curing organic zincs nowadays. And because they have accelerators and they have faster recoat windows with organic zincs, they become more popular in the shop.
For production reasons, it sounds like.
For production reasons.
Recoat it rather quickly and get the
Right.
steel out the door.
And another issue with the organic zincs in the shop is The inorganic zinc primers, when they're applied too heavily, they have a tendency to mud crack. Mud cracking can become a problem for application of the coatings because we have to remove the mud cracking if we have extra thick coatings. Organic zincs are more forgiving in those terms. They don't have the mud cracking problems like inorganics have. Therefore, if we have a more complex configuration that we're applying the coatings to, we can have more forgiving properties of the organic zinc. We don't have near as much mud cracking.
All right, Bill?
And I'm actually a proponent of using or even going with tradition, if you will, and continuing to use the inorganic zincs for shop applications because the environment isn't necessarily controlled, but it's controllable. And what I mean by that is some of the difficulties or challenges that I was talking about earlier and Jim talked about as well, which included, over thickness. Again, training can handle that. Applicator training and certification can handle that. Overspray, dry spray, again, those are application issues that can be overcome. Outgassing, whenever a mid-coat is applied in the shop, in the case of total shop painting. That can be taken care of by mist coating, applying a mist coat prior to a full coat over the inorganic zinc. The lack of relative humidity or humidity in the shop, that can be overcome by misting the inorganic zinc down with water after a couple hours of set time or cure time to accelerate that or promote that curing process if the humidity in the shop is low, particularly in the winter months whenever the heat is a little bit higher. So all of those can be overcome. And you do have, again, the greater zinc to zinc contact, the greater zinc to steel contact. And in fact, inorganic zincs are routinely used today. The Pennsylvania Department of Transportation, for example, continues to use inorganic zinc primers as their shop primer for new steel. Another argument that you occasionally hear is that with the organic zincs, like an epoxy zinc or urethane zinc, you can actually lower the degree of surface cleanliness that's required. Inorganic zincs, typically they need a near white blast, where the organic zincs you may be able to get away with a commercial blast. But for new steel, what we have to remember is both the near white and the commercial blast require the removal of 100% of the mill scale. The only difference between the two is the percentage of staining that's allowed to remain. So for new steel, by the time we remove 100% of the mill scale, we're essentially going to be at a near white blast. So where there's a perceived economical benefit by lowering the degree of surface cleanliness, it's probably not really there.
All right, so it sounds like you're both agreeing inorganic is a little more difficult to apply than organic. Bill, you feel that those challenges can be overcome. And I know that, as you both mentioned, the inorganic requires moisture to cure, which could potentially affect the ability of the shop to put a new coat on and a second coat the next day or maybe even 30, 40 hours later, depending on the humidity in the air. But Bill, you're saying you can overcome that by misting water on it, on the zinc, to enhance that cure if you're in a dry climate.
Certainly, and I would add on to that there are even methods now that can be used, ASTM standard methods, for verifying that you do have a good cure on the zinc, which is really, really important. It's a methylethyl ketone solvent rub test. We don't want to assume that because we've waited the allotted amount of time or that we've misted the zinc down with water that we've achieved that cure. So we're going to verify that using a standard solvent rub test.
And that test is for inorganic zinc?
Inorganic zincs only, yes.
Okay. All right, so given the application challenges you've talked about, especially for the inorganic zinc, and Bill, I know you say that can be overcome. Let's assume now that all three coats are being applied in the field. So there may be some wind conditions, perhaps much more complex shapes. You have an old bridge that's got lacing bars and things compared to the new steel in the shop. A little more complex configuration. I'd like to see if that changes your opinions as to which primer you would apply. Let's start with you, Jim.
Well, by far the most common primer used in the field is the organic zinc-rich primer. Typically, for the reasons you mentioned, when we get on bridges, we have many complex configurations. We have gusset connections with multiple verticals and diagonals entering into the connection. We have inside of box girders, we have lattice box beams, we have rivets, we have nuts, we have bolts. All those things present application problems. Because the organic zincs are much more user-friendly, we are able to apply them easier to these complex configurations, whereas with inorganic zincs, we're very much limited because they dry so fast. We're limited to application to spray, and when you do brush, it can become problematic. If you can brush limited areas with inorganic zincs, but when you start getting into larger areas and larger tight configurations, organic zincs by far have the advantage in the field.
Yeah, and to answer your question, it does change my mind. I would probably yield to using organic zincs in the field. Even if the work is done inside containment, you still don't have very good control over conditions. It's very difficult to apply them, as Jim indicated. If you have a simple structure, it can be done, but if there's any complexity at all, it's going to be very, very difficult. You're going to end up with a lot of mud cracking issues, so I would probably yield to using more organic zincs in the field.
Okay.
And I have seen inorganics used in the field, but like Bill said, on those cases, we had very deep girders on the bridges with a lot of surface area, not a lot of complex configurations. And there are some bridges that are designed that way, but typically what we do not see inorganics used very much in the field.
Well, let me ask this. Now let's go back to the shop for a second. Let's say I'm only applying the primer in the shop, the intermediate and finish in the field. Which primer would you think is better in that situation? Bill, I'm going to start with you this time.
Yeah, in that case, I like to see inorganic zincs used. If it's shop prime only, they're very durable. You don't have a recoat interval with those. So, for example, if the shop steel's primed and it gets mobilized to the field and it's not field top coated for several months, all you got to do is pretty much just pressure wash it to get the zinc salts off. It's not going to be degraded by solar radiation from the sun. And again, you're going to get probably better protection in the long term.
Well, it depends on the long term we're talking about here. I agree in theory that inorganic zincs are probably better if you're going to shop prime the steel and leave it sit in the field for a long time. However, we do see a lot of organic zincs now that have extended recoat windows.
Like what does that mean by extended?
Extended recoat windows, for example, up to a year. Now, what happens is typically the projects where we're having the steel come out and shop primed, it's usually erected and the intermediate and the finish coats are usually started within a year. On larger projects, I would agree that there's an advantage to using the inorganic zincs because of their unlimited recoat windows. But organic zincs nowadays, because they're highly loaded with zinc and they have a rough surface texture for physical surface texture themselves, they do have extended recoat windows, and we don't see the problems that we used to see. With regards to degradation by solar radiation or degradation by sunlight, epoxy binders inherently have the tendency to chalk when they're exposed to sunlight. So when you have an organic zinc primer that's an epoxy binder with zinc rich in it, you're going to have a tendency to have some chalking. But no matter what you do, inorganic or organic zinc in the field, if it's a year later, they're typically going to be pressure washed before they're painted anyhow. And pressure washing typically takes care of all those problems of chalking or surface dirt, or even if the zinc salts form on the inorganic zinc primer.
All right, so for the epoxy zinc, let's say that, in the field, I can in fact prepare it by pressure washing. I don't have to go abrade it or anything like that prior to putting the intermediate on.
With most of the formulations we have now, if they have extended recoat versions, yes, we don't have to go abrading the existing coatings to recoat them after an extended time period.
Good. Now, Bill, you mentioned zinc salts. I know that the inorganic zinc will get covered with that the longer it's exposed. Does every bit of it have to be pressure washed, or can I still have some in the porosity of the zinc, so to speak?
Yeah, I think it's going to be very difficult to remove 100% of the zinc oxides, and in fact, some of that zinc oxides will help fill those pores and potentially reduce some of the outgassing issues related to putting the second coat on. So removal of the majority of it would be helpful, but 100% removal wasn't necessary.
Okay. All right, let me go to top flanges. Many times for bridge steel, you're going to put the zinc on the top flange only, and they want to put shear studs, attach shear studs. Which primer would you suggest in that case? Jim?
Well, we see use of both, but I believe if you're going to do shear studs, and a lot of it has to do with the sequencing of the work. If they're just exposing the top flanges and they're blast cleaning them and they're going to shoot shear studs on the top flange with only those areas exposed only, I would probably prefer to use the inorganic zinc to prime the top of this flanges that's going to shoot shear studs. Some inorganic zincs, if you keep the thicknesses at the proper level, you can shoot the shear stud right through the zinc. But the problem is when we get an application in the field, we have a tendency to apply coatings a little bit thicker. The inorganic zinc's thicker, so we have to grind to put the shoot the shear stud. So we have to grind to bare metal, so we shoot the shear stud into bare metal. But if the application thickness of the inorganic zinc is controlled properly, we can shoot the stud right through the inorganic zinc
But
coating.
typically you would say grinding is going to be required.
Typically
because of
grinding will be required
thicknesses.
because of the thicknesses, right.
Well, he sort of made the case for inorganic, Bill. Do you have anything to add?
No, I agree. I think if the inorganic zinc can be applied very thinly to the top of the top flange, that you could shoot the shear studs right through there. But ultimately, I like to see the inorganic zinc ground away to get a little bit better application of those studs.
And so, Jim, we could use organic as long as we grind, though, correct?
We could use organic, and in fact, we do use a lot of organic,
Okay.
but we have to grind it away to make the shear stud.
Okay. So it's probably a good rule to just plan on grinding to be safe. So what about untop coated? Let's say that I'm only putting one coat on, and I'm not worried about aesthetics. Let's take that away for a moment. Which would you do as a single coat system, given the proper pH and things like that? I'm not worried about chemical exposure. Inorganic or organic zinc for outdoor exposure?
Well, I guess, I can make an argument for using inorganic zincs. They can be used outdoors as long as you're not concerned about aesthetics, because the zinc is going to begin to oxidize very quickly, but it's not going to oxidize uniformly across the surface. You're going to have a streaky appearance, but again, that oxidation will help fill some of the pores, and it's just the nature of the type of coating it is. Now, one of the things that's important to remember, and you did address, chemical exposure and that kind of taking that off the table, but we have to remember that zinc is an amphoteric material, and that's very sensitive to low or high pH. So if you have either of those conditions, you have to be very careful about using on top coated zinc as the total system. But if it's a neutral pH environment, it would work fine.
Give me the range. You say low to high, but roughly what to what?
I would say I would say as low as 6 and probably as high as 8 or 9. But outside of that range, I'd be uncomfortable.
Okay. Jim, any thoughts on?
Well, organic zincs don't have the reactivity problems with pH like inorganic zincs do. Inorganic zincs are more reactive with the environment when the pH varies and even if the temperature varies a little bit. Organic zincs, because they're dispersed in organic zinc-rich binders, they have the tendency to take on the characteristics of those binders, and they'll actually perform better in a single coat exposure environment. The problem with epoxies, again, is they have a tendency to chalk, and they might have a tendency to discolor with exterior exposure alone. Given the fact that we're going to have a zinc-rich coating in exterior exposure, I don't think that organic zincs or inorganic zincs really make a difference. They're both going to have their aesthetic problems after they're exposed for a while.
Okay. All right, good. What about repairs? Are they easy to repair? The primer, is it easy to repair? Or is it challenging? And how do you repair them? Damage and things.
Sure. I mean, for inorganic zincs, you can repair them with an inorganic zinc, but the initial application better be pretty green. In other words, it cannot be fully cured, and then you can do some touch-up with inorganic zinc. But if it has gone through a cure, I would highly recommend going with an organic zinc for repair of the materials. In either case, the inorganic zinc, whether it's a new application or repair application, they're spray materials. Very, very small areas can be touched up with a brush, but pretty much you're looking at a spray application.
Well, I prefer the organic zincs for field touch-up, obviously. They can be cleaned, and we can roughen the area around the touch-up area. One nice thing is they brush apply better. If we're going to do field touch-up, with organic zincs, they brush apply much easier. A lot of times in the field, because of the brushability characteristics and the recoating characteristics of inorganic zincs, we will touch up inorganic zincs in the field with organic zincs. We get the same, essentially equivalent corrosion protection, but we have the ability, because of their applicator friendliness, to apply them.
Okay, so you both agree, touch up inorganic with organic. Inorganic is easy to touch up with organic.
Sure. Right.
All right, I think a final question. There's a lot of talk about Class B slip resistance for slip critical joints. Do these primers both achieve Class B, which is the highest level? Jim, I'm going to start with you.
Well, virtually all the organics that we see in, for example, on the NEPCode approved list of products and a lot of the DOT lists, they virtually all have an A slip. There are products, and a lot more products now with the organic zincs, that do have B slips. So we have both A and B slips with organic zinc rich coating.
Okay, but not all the organic is typically as good to a B level. So
not all organics are typically to a B level, but with your major manufacturers, due to the need for slip creep resistance, it's driven them to test some of their organics. And there are organics out there that have a Class B slip.
And on the inorganic side, for me to say that 100% of all inorganic zincs will pass Class B slip coefficient, I don't have any evidence of that. But I'll say the majority of inorganic zinc-rich primers with, a level 1, 2, or 3 zinc loading will likely be able to pass Class B slip coefficient with little difficulty.
All right, good. Any final questions before we wrap this up, or comments?
I'm a big organic zinc guy. The market has driven the organic zincs to the point where they're usable in the shop now. They don't have the problems with curing that they used to have, prolonged cure times, which made flow through the shop difficult. So they flow through the shop better. They may not provide the same level of galvanic protection as do inorganic zincs, but in light of the application characteristics, I think, and the ability to apply them better, once we get out into the field, I think that may be a moot point. The galvanic protection is still excellent, and the applicator user friendliness of the product just makes it much more easier to use.
Yeah, and I guess that's the question is, if organic zinc-rich primers, the advantages or their advantages outweigh their limitations, you would think that we would see a strong trend towards more organic zincs being used for both shop and field application. But we still see a lot of inorganic zincs used. Now that might be because people are reluctant to change. They have confidence in the performance of inorganic zinc-rich primers. There can be a variety of reasons, but both products are still readily available, manufactured by, as Jim said, a lot of the major manufacturers make both. So I think that an argument can be made to use either one, depending on owner preference and ultimately what their goal is. If you are painting new steel, the intent is for that steel to last a long time. You might want to invest in perhaps a little bit better galvanic protection that the inorganic zinc would give you versus the organic zinc.
With regards to using inorganics or inorganics, we're seeing an increased use of organics in the field and in the shop. For all the reasons we mentioned earlier, when we talk about the advantages of galvanic protection of inorganic zincs over organics, you have to remember that one thing in the field, that's assuming that we're always going to have the zinc exposed and it's going to be reactive. In the field, we're taking the organic zinc and the inorganic zinc and we're coating over with a coat of epoxy intermediate and a coat of a urethane finish, which protects the organic zinc and the inorganic zinc from being exposed to the environment. So once we do that and we're protecting the organic or inorganic zinc-rich primer, I think that the differences between long-term corrosion protection probably do not outweigh the application characteristics of the organic zinc.
Jim, you just brought up a good point I want to pass to both of you. Let's talk about that. You've got all coats on in the field, I agree with what you said, but now I have a breach in the coating, a scratch in it. Which one do you think is going to resist undercutting corrosion better, inorganic or organic? And I know NEPCOAT has different criteria for undercutting for inorganic versus organic. Mm-hmm. Bill, what do you think? Which one do you think is going to resist it better?
Well, of course, I'm going to be a proponent of inorganic zinc in that case, because when you do get a breach in the coating system, you've got exposed metal. So because you have more zinc, it's probably going to have a little bit better throwing power to protect that initially unprotected
More zinc
area.
or more zinc contact?
More zinc to zinc contact and more zinc to metal contact. So it'll have the ability to protect that area. And it's interesting you did bring up the fact that NEPCOAT does have a tighter scribe undercutting criteria for inorganic zinc versus organic zinc, because I think they recognize that the inorganic zincs should be capable of protecting better in that case.
All right, well, thank you. I guess to sum it up, it appears there's no real clear-cut answer one way or the other. Both products have their advantages and disadvantages, and we've heard that. It sounds like the inorganic might, in theory, give you better galvanic protection, but with the application difficulties, you may not see that in practice. It sounds like for total shop painting, we're seeing both systems still being used, but for the field, it seems as if organic zinc may be the better choice because of tough configurations and more user-friendliness. For shop primer only, it sounds like you can go with either, but it sounds like inorganic may be fairly common in that regard with the finished goods in the field. So it depends on a case by case. Looks like either product is going to be very suitable for your needs. Just recognize the advantages and disadvantages and challenges in using them. So that's the end of this podcast. Thank you for watching us, and please join us again in the future for our next one. Thank you.